All right, guys, this is the next section, 6.3, and this is going to be arcs and angles. Okay, so let's review again what an inscribed angle is. Remember, it is different from the central angle. Okay, this one has its vertex, which right there on the circles. So it's an inscribed angle if its vertex. Let me get a smaller pen. So its vertex is on the circle, and then the two sides, so meaning this piece and this piece from there to there, is those are chords. The two sides of the angles are chords. I know you see that this one is extending out that way, and that's fine. This can extend out this way, but remember, it's just going to go from there to there. So I'm going to highlight what you're looking for. So from there to there and there to there is an inscribed angle. So we're going to use this a lot on this lesson here. Okay, so speaking of inscribed angle, it says the measure of an inscribed angle in a circle is, okay, so let's go ahead and draw our inscribed angle. So I'm just going to pick a chord like this and then a chord like this. Make sure that they actually touch. Okay, and y'all can just sketch these right here. So this arc right here that I'm about to highlight in pink is related to this angle right there. The question is how are they related? So I'm going to take you back to remembering what this arc is. So if I go from there to there and there to there, that angle right there is a little bit bigger. Okay, this angle is bigger than this one down here. So I want you to recall that if this angle here is, looks like it could be, I don't know, let's just say 100 degrees. Well, then that means this arc is 100 degrees. Now, does that mean this angle is also 100 degrees? That cannot be true because this angle here at the center is much larger than that one. So the question is what would it be? So I'm going to get rid of that 100 because it's not 100, but it is related to it. And I probably should have got the protractor out instead of just make up 100 degrees. But when I put this right here, it's actually 110 degrees. Okay, so I'm going to go change that real quick. So this is 110 degrees, which means that arc has to be 110 degrees. So what we're truly trying to find out is what the inscribed angle is. And so when I put this here and I line it up there, it is 55 degrees. Okay, so I'm going to put a 55 right there. So how is the inscribed angle related to its intercepted arc? It is half of its measure. So the measure of an angle inside the circle is half the measure of its intercepted arc. Okay, so got to remember that. So this inscribed angle right here is related to its intercepted arc, and it's half of that. Okay, so a lot of people get these two angles mixed up, so keep that in mind. All right, next one. It says an angle formed by a chord and a tangent. The measure of an angle formed by a chord and tangent. So let's draw a chord. So here's my chord. And then my tangent is going to go something like this out here. So you want to make sure that's lined up. All right, so this angle right here that goes from there to there, that angle is related to its intercepted arc. And here's the intercepted arc. I'm going to highlight it in blue. So it goes from there all the way to there. All right, and so that angle is related to that arc. How is it related? It's the same situation as an inscribed angle. So if this red angle here, let's see, that looks like that. That one looks more like 100 degrees. So if that is 100 degrees, then the blue arc is going to be double that. So this blue arc would be 200 degrees. Okay. So we're going to write that down in this conjecture. The measure of an angle formed by a chord and a tangent is half the measure of its intercepted arc. Okay, so that right there. And you can carry it on the other direction as well. So if I were to extend this tangent, let's see, like that. So over here, I'm gonna get a different color. This angle right here would be 80 degrees, right? Because of the linear pair. So if that green angle is 80 degrees, let me get my highlighter. This arc right here is its intercepted arc. And so if that's 80, remember you want to double that to get that measure. So this arc over here would be 160. Makes sense, right? Because the two arcs need to add up to 360 degrees. Okay, so remember the measures of those angles. Next one, inscribed angles that intercept the same arc. So I want to make two inscribed angles. So here's one. We're going to go here and there. And then I'm going to make another inscribed angle, but they have to intercept the same arc. So I'm going to go here and there. Okay, so the red angle is an inscribed angle and the blue angle is an inscribed angle. And I'm going to highlight its intercepted arc. Okay, the intercepted arc goes from here to here that I just highlighted in pink. So let's pretend that the inscribed angle is, I don't know, looks like it could be about 150 degrees. So if that's 150 degrees, this red angle down here is going to be 75. Well, the blue angle intercepts that same arc, and remember, these are inscribed angles. That has to also be 75. So when you see two inscribed angles that intercept the same arc, they are congruent. Okay, because of the inscribed angle rule. They're half of its intercepted arc. Okay, the next one says angles inscribed in a semicircle are blank. So since we're dealing with a semicircle, we have to draw in a diameter here. So draw a diameter that passes through the center. And then we are going to make some inscribed angles that go in the semicircle. So here's one. And then right there. Okay, and then let's do another one here and there. There's a purple inscribed angle, a black one. Let's do one more. And so the question is what are the measures of those angles? So I want to get my highlighter and I want to highlight its intercepted arc. So its intercepted arc goes from there to there. Now, as I'm highlighting this, you should know the measure of that. The measure of that arc is 180 degrees because it's exactly half a circle, a semicircle. So if that's 180 degrees, remember its inscribed angle rule is half of its measure. So that means this must be 90 because half of 180 is 90, which this is also 90 and that is also 90 because they all intercept the same arc. So angles inscribed in a semicircle are right angles. Okay. So anytime you see an angle inscribed in a semicircle, then it's a right angle, which you should see some right triangles here. So right here, as I highlight this right here, there's a right triangle. So don't be surprised if you have to do Pythagorean theorem in some cases, or use trigonometry for right triangles. All right, next conjecture. It says a quadrilateral inscribed in a circle is called a cyclic quadrilateral, okay, or cyclic, however you want to say it, okay? So there's something unique about this quadrilateral, okay? And it has to deal with its opposite angles. So what I'm going to do is I'm going to highlight here. So here's an inscribed angle that I just highlighted in green. And then the angle opposite it, I'm going to put in blue, that's across from it. There's something unique about those two measures. So I'm going to highlight its intercepted arc. So this blue angle, this is the intercepted arc for the blue inscribed angle. The green angle, here's the intercepted arc for the green angle. Okay, and so what do you notice about the blue arc and the green arc? It makes the full circle. Well, the full circle is 360 degrees. Well, since the whole thing is covered, and remember, inscribed angles are half of its intercepted arc, then that means that this angle and that angle, they both add up to equal 180 degrees, because half of 360 is 180. Same thing goes, guys, for this angle over here and that one there. Those two right there also add up to be 180 degrees. So whenever you see a cyclic quadrilateral, okay, or an inscribed quadrilateral, okay, about a circle, just remember opposite angles add to equal 180 degrees. Always and forever, okay? All right, last conjecture. It talks about parallel lines that intercept or intersect a circle. So I'm going to draw a pair of parallel lines with my ruler. You can do the same too, make perfect parallel lines. It's kind of cheating, but we'll just go with that. So the question is, it says they intercept what type of arcs? So I'm going to highlight these two arcs in red. So that arc, they want us to compare to this arc right there. Okay, they look like they could be equal, right? If you wanted to be sure that they were equal, you could always go and compare it to their central angles. So if you connect central angles there, and then you were to go measure those central angles, this is going to be hard digitally. Okay, there we go. Even this one needs to be right on there. There we go. And so if you were to go get your protractor and actually measure those, they would be pretty much exactly the same. So this one here looks like it's about 42 degrees, and this one over here about 42 degrees as well. Okay, so remember, if their central angles are 42 degrees, if that's 42 and that's 42, remember its intercepted arcs are also 42 degrees. So parallel lines intercept congruent arcs on a circle. Okay, so if you ever see parallel lines, remember these two blue lines are parallel, then those two arcs that are in between are congruent. Okay. All right, let's test, let's try using some of these properties on these examples. Here it's asking us to find the measure of angle A. So we want to use its intercepted arc. So remember, this arc right here, or this angle, intercepts this arc. Well, guess what? This arc also intercepts this central angle here. So that means this is also 130. But this angle A is not 130, it's going to be half of its intercepted arc. So that one is 65. All right, over here we have a quadrilateral inscribed. Okay, so we have a cyclic quadrilateral or cyclic. And so remember we learned that opposite angles equal 180, right? So that must mean F has to be 90. Okay. And then if it works that way, well, we can work it the other way as well. If this is 75, then that means this angle here has to be 105. So if that's 105, let me get my highlighter. If that's 105, then that means this arc right here that I just highlighted in green, it intercepts this arc, this angle, which is 105. That means that big green arc is 210 degrees because you want to double 105. So if that's 210 and over here is 110, that leaves G to be 100 degrees. So G is 100 degrees. So you got to use the inscribed angle rule to do that. Let's look at these two down here. I have to find the measure of arc B. Okay, well, it's related to this angle. So if I find that angle there, I can use that, or I can find this arc here. So there's a couple ways you can do that. I think finding the red arc might be easier because you'll know that you just have to do something to 58 because this is an inscribed angle for that. So doubling 58 takes me to 116. And then you should notice that this is a diameter. So that means this whole arc over here is 180. So that leaves B to be 64 degrees. So B is 64 degrees. Okay, over here, I'm looking for the measure of angle Y and the measure of arc X. So arc X goes from there to there in green. So I need to find the measure of that. One thing I want you to notice is that this angle 60 also intercepts that same arc. Okay, so see how this angle that is 60 degrees intercepts the same arc? Well, that's an inscribed angle. So X is not 60, but you have to double it because that's the rule for an inscribed angle. So X is 120 degrees. And then angle Y, you'll notice that intercepts that same arc. So it carries that same property. This is a tangent and a chord, which it's not an inscribed angle, but it has the same property as an inscribed angle. So you take the 120 and you divide it by 2, and so Y is half of its intercepted arc, which is 60 degrees. So Y is 60 degrees. A couple more examples and then that's it. I have to find the measure of arc H on this one, which goes from there to there. A lot of kids have had a hard time with this one because they don't know what to do. They'll probably just go ahead and guess and see, oh, if that's 40 degrees, then that must be 40, which that is wrong. So don't guess 40. What you do need to do is you need to connect the radius here, and you need to recall this property back from 6.1, that's 90 degrees. Okay, so you learn that whenever a radius goes to a tangent, okay, and the point of tangency, that it is going to be 90 degrees. So if that's 90, then that means this central angle right here must be 50 degrees because of the 180 rule. So I'm going to write it out there because it's a little too small. So if that's 50 degrees, then that intercepts that same arc. That means H is 50 degrees. Okay, because the central angle and its intercepted arc are the same. So sometimes you need to draw these radii in to help yourself out. All right, problem. I have two parallel lines that I want to highlight there so you can notice that. So this is parallel to this, which you should know that the arcs in between are going to be congruent. So I'm going to put tick marks on those right there. So those are congruent. So I got to find the measure of arc X here. Well, this angle here that I just colored in blue is 40. So that's related to this arc here because that's its intercepted arc from that inscribed angle. This angle right here is 60 that I colored in green, which is 60 degrees. That is related to this intercepted arc. So the question is what are the measures of those arcs? Well, the green arc is going to be double 60, so that green arc is 120. And this blue arc is double 40, so that means that blue arc is 80. Okay, remember these are for the arcs. So the whole circle is 360 degrees. So if I subtract 200, which is the 120 and the 80, that leaves me 160 degrees, which leaves the two pink arcs right here, because I have to divide that by 2 because they're equal, to be 80 and 80. So that's 80. So it just so happened to be, these three arcs happen to be 80. But arc X is 180 degrees. And that's it.